All right, guys, so we're finishing up the note sheet from yesterday. Now, are there any questions on any of the assignments before we get started? So this one here is not on the note sheet, so you'll need to add it in. I think there is some space on the back of the note sheets if you want to put it there. But I do want to look at this one here because I want us to look through one that has variables in both terms. So when we look at this here, we're looking at, hopefully, probably, a difference of perfect cubes. Now, for us to be able to tell or check to see if it is a difference of perfect cubes, we can take the cubed root of both terms. So take the cubed root of 192x cubed, as well as the cubed root of 81y cubed. This will help us to be able to determine if they are a difference of perfect cubes, as well as being able to tell what the two terms are. Now, looking at both of these here, well, 192 taking the cube root is kind of hard for us to be able to just tell by looking at it. But x cubed, the cube root of x cubed would be x. 81y cubed, well, the cube root of y cubed would be y. Now, we can use the calculator to figure the other two out. So if we want to see what the cubed root of 192 is, we can go math down to the cubed root and plug in 192 and hit enter. And we see that the cubed root of 192 is not a whole number, it's 5.7689 and continues on indefinitely. Math. And if we look at the cubed root of 81, we see that it's 4.32. It's not a whole number either. Okay. So neither one of these are a cubed root. But is there a greatest common factor between the two? Is there a number that will go into both of these here? Well, it works out that there is one. It is 3. Both of these numbers are actually divisible by 3. Now, if we divide 192 by 3, we get 64. 81 divided by 3 is 27. So we can check this again and see, now can we take the cubed root of 64x cubed and see if we can take the cubed root of 27y cubed. So we'll see if we can take the cubed root of each one of these here. Now the cubed root of x cubed is actually x. The cubed root of y cubed is still y. Now we can use the calculator to see what the cubed root of 64 is. So we can go math, go down to the cubed root, and hit enter, and plug in 64, and it tells us that it's 4. Go math, pull up the cubed root of 27, and it is 3. So we can actually take the cubed root of both of these here. We have 4 and 3. So this one here is a difference of perfect cubes. We just had to take out a greatest common factor of 3 first. After we set up our two sets of parentheses, one with 3 spaces and one with 5, our tractor trailer, we can find the signs. And the signs for these here are going to be the same, opposite, always end on a positive note. So since we're starting off with a subtraction, to be the same, it would be minus. Then we would have plus, and plus. Same, we match, so minus, opposite, so we would have plus, always ended on a positive note. Now we look at this here, which one of these two came first? Well, 4x, so 4x will go first. And then here we will have 4x squared. 4x to the first, and then 4x to the 0, which works out to be 1. Our other term is 3y, and it came second. So in our first one, it will come second. Next to the 4x squared, it would really be 3y to the 0, which is just 1. In the middle, we'll have 3y to the first. And lastly, we will have 3y squared. So when we simplify this here, we'd have 3 times 4x minus 3y. Now our 4x squared will simplify to 16x squared, because our 4 squared would be 16, and x squared is, well, just x squared. In the middle, we're going to have 4x times 3y. Well, 4 times 3 is 12, and then we would have xy plus 3 squared is 9, and y squared is just, well, y squared. And that's it. Any questions on any of this here? Any questions on anything we've done so far? How do we feel with the sum and difference of perfect cubes? Feel pretty good with these here? All right. Let's look at one last one. I want to look at this one here, mainly because it's a little different in that the variable goes second. Now, this one here is not going to work any differently than the ones we've done earlier. It's just that the variable is second. Huh? We can leave it as this. So we don't have to move it because it's still going to work the exact same way. Now, we can check to see if it is, both of these are perfect cubes. And well, they are, because the cubed root of 125 is 5, and the cubed root of x cubed is x. So this does work. Now, what would our signs be? Minus, plus, and plus. Now, which number came first, or which term? The 5 came first, yes? So it will go first. And inside the bigger one, we would have 5 squared, 5 to the first, and then 5 to the 0. Now, because the x cubed came second, well, the x terms are going to go second as well. So we'll have x to the 0, x to the first, and then x squared. So it's working out the exact same. It's just that the variable is now going in the second spots instead of the first. Any questions on this here before we simplify? Now the first set of parentheses, we can leave it as 5 minus x. And the second one, well, 5 squared is 25. Plus 5 times x is 5x plus x squared. Now, if we wanted to, I would leave the first one as 5 minus x, But we could actually rewrite the second one as x squared plus 5x plus 25 because we can rearrange that order. Any questions on this here? I just like it better in the second one in standard form because it just looks a little bit nicer. It might just be me. And it just looks a little funny having 25x plus, or 25 plus 5x plus x squared. But either one of these is still in factored form because they are factored down. I don't switch the 5 minus x to negative x plus 5 because I don't like having that negative in front of the variable, especially if it is in front inside parentheses. It just looks a little weird. Any other questions? All right. The last thing we're going to look at is factoring by grouping, or greatest common factor twice. And whenever we factor by grouping, we need to do it with an even number of terms. And we're going to group them together. So here we have 4 terms, so we'll group them in pairs. So what we can do is group the first 2 and the second 2 together. Or we can group them in any pair of 2's that we want, because I could have grouped 2p and 6p or 5p squared and 15. But we can kind of group them any way, but we need them in the same number of pairs. So 4, we're going to do 2 and 2 in any way. We can't have 3 and 1. We need an even amount. So when we look at this here with these 2 pairs, is there a greatest common factor between these first 2? Is there something in common with both terms? They both have p, so I could factor out what? P squared. Because there are 2 p terms in both 2p cubed and 5p squared. They both have a greatest common factor of p squared. Now if I take 2 p's away from p cubed, I'm left with 2p. If it has 3 and I take 2 away, I'm left with 1. Plus 5. Because if we have 2 of them and I take 2 away, they factor out completely and I'm left with p. Now if a term factors out completely, we take everything away from it, what is left? 1. Because whenever we factor something out, if I had factored 5p squared out of 5p squared, I would be left with 1. They won't eliminate completely. Plus, what is the greatest common factor between 6p and 15? 3. Okay, so let's factor it out. So 6 divided by 3 is 2, and I have p plus, okay. Is there something interesting that you notice what we have now? The parentheses are the exact same, yes? And that's what we want to have happen. Because I called this factoring by grouping, and that's what this is. I kind of like to call it greatest common factor twice. Because we found the greatest common factor between those 2. Well, now do they have a greatest common factor between those 2? But yeah. And what we can do is we can actually factor this here out of both. And if I factor 2p plus 5 out of both of these terms, well, the first one I'm left with is p squared plus, and that's its factor. And that's all we have to do for this here. And this is factoring by grouping because we're grouping it together and factoring out greatest common factors so that they will match up that each one of the sets will have a common factor in it that we can pull out again. Now, one of the things I would say is this has to have a even number of terms if we're doing this. So it doesn't always have to be 4. We could actually have 6 or 8 or 10 and be able to do this here, as long as we have an even number. Because if it's odd, we're going to have an odd one out. Because no matter how we factor it out, either the parentheses or the setup is going to have an extra number in one of them, and it won't work. We need them to be the same. And that's what the main goal is. Then if these aren't the same, then we need to find a way to make them be the same, because we need to have that commonality. Does that kind of make sense? Either these need to be the same or these need to be the same. We need them to have something that is the same so we can pull it out and factor it again. So let's look at this one here. So we can do the first two and second two. 3n cubed minus 4n squared plus 9n minus 12. Looking at the first two, what is the greatest common factor between 3n cubed minus 4n squared? N squared. Now if we factor this out, 3n cubed, and we factor out n squared, we're left with 3n, and then we would have minus 4. So for the second one here, what do we need to have inside the parentheses? We need this to turn into 3n minus 4. So if I factor 3 out of 9n, I would get positive 3n, yes? And if I factor 3 out of negative 12, will I get negative 4? Yeah, so we can factor out positive 3. And those would be the same. Because again, we want those parentheses to be the exact same. And it does work out that 3 is the greatest common factor between these two here, which does give us another set of greatest common factors that we can factor out. So we'd factor out 3n minus 4, which would leave us with n squared plus 3. Now when factoring, one thing that's nice to look for, and probably should have mentioned this the other day, is looking at each one of these terms individually and seeing the degree. For 3n minus 4, what is the degree of that polynomial? 1. Because if we get to a degree 1, we're done. That is as factored as it can get. Now if we look at n squared plus 3, the degree is 2. So we need to make sure and look at it to see if it will factor. Because if the degree is 2 or greater, we need to double check to make sure that it won't go any farther. Well, we only have 2 terms, n squared plus 3. Well, the only way that we have 2 terms and it factors is if it's a difference of perfect squares. Well, this one's not, so this is actually as far as we can take it. And this here would be considered factored completely. The only way they would want us to take this further, kind of like with the x plus 3i and x minus 3i yesterday, is if they specify not just factor completely, but to find the complex roots, factor and find complex roots or irrational roots. They will specify if they want you to take this further. But this here is considered factored completely, because this here would actually turn into n minus I square root of 3 and n plus I square root of 3 if we went through the same steps as yesterday with the, I think it was x squared plus 9 to find those 3i negative 3i. But this isn't required to find it just factored completely. Any questions on this here? Let's look at one more. Let's look at this one here. Now, looking at this here, it might be a little challenging to see what we group, because most of the time we would group the first two and second two, yes? But as I'm looking at this here, I see that 24, we have 224 AZ, 56 AC, negative 84 YZ, and negative 21 YC, yes? So looking just at the variables, well, the first two both have A, and the second two both have Y. Okay, so those share something in common. We have 24AZ, so we have a Z and a C, Z and a C. So most likely inside both those parentheses, I'll need a ZC, ZC, because those would match up across the two. Yes? We also have C, C, Z, Z, so I could match those two up. So how we match the two up is up to us to see which one do we think is going to be easiest to work with. These two and these two? Okay, so we can say 224 AZ minus 84 YZ plus 56 AC minus 24 21 YC. Now looking at these first two here, they do have a common factor of Z. Now what's the greatest common factor between 224 and 84? Oh, 4. And we can take 4 out. So if we take out 4Z, 224 divided by 4 is 56. A, and the Z factors out. Minus 4 goes into 84 21 times, and we're left with Y. Now what do we need to factor out of the other one? Well, what do both of these have in common? Well, yeah, we can just take out the C because we need the first term inside the parentheses to be what? 56A. What do we have? 56A C. So I could say 56A minus. So I've got both of the parentheses to be the exact same. Well, we could find out what it is if there is one, but all I'm really focused on is making these two be the same so that we can factor out the 56A minus 21Y from both of them, leaving us with 4Z plus C. It would, yeah, because we need these two to be the exact same. Because 56 and 21, because 21 would be, well, 21's factors are 1, 3, 7, and 7. So all that means is that we could actually, if we wanted to, between these two here, there is a greatest common factor of 7. If we wanted to pull it out, we could pull it out and say 7 times 56 would be 9? No. 8. 8a minus 3y times 4z plus c. And then that would technically be factored completely. But I would take either one of these. We would just have to factor that 7 out later, because if we factored it out before with the c, the two sets of parentheses wouldn't match up anymore. It just really means at the get-go, all of these were divisible. Yeah. Any questions on this here? Well, that's actually it. That's all we're doing for